Okay, we've got a question all about buoyancy here with this submarine and its buoyancy tank here, rising and falling. Okay, first question, it's talking about these gears in the submarine's engine. A has 30 teeth, B has 20 teeth, but we're told that A rotates clockwise, okay, for 1 turn. What will B do? Well, if A rotates once and has 30 teeth and B only has 20 teeth, for the first 20 teeths worth of rotation of A, that will rotate B once. But then you've got another 10 teeth to go, which will rotate B another 10 teeth, which is half a rotation. So overall it's 1.5 rotations. Okay, so B will have 1.5 turns or rotations, okay, and if A is turning clockwise like so, that means this bit is going in that direction. It's going to push that part of B in the same direction, right? So B is going to be pushed in that direction, which is anti-clockwise. So if one gear turns clockwise, the other turns anti-clockwise. Anti-clockwise. Okay, easy. So B 1.5 turns anti-clockwise when A goes clockwise for 1 turn. Good. Right. Now, a bubble escapes from this submarine, okay? And we're told that its, let's have a colour change, its volume is 23 cm cubed, okay, 23 cm cubed. This is for some bubble. Its pressure is 297 kilopascals. It rises to the surface with no change in temperature, okay? And we have to work out, so temperature is constant, and we have to work out the volume of the bubble at the surface. Okay, so here's the bubble, it's rising up, it gets to the surface, there's air, water. It gets to the surface and it's going to be bigger. Good. So the bubble's rising up. And we're told that the atmospheric pressure is 101 kilopascals. They tell you to use the equation from the formula sheet. Right, well, if you look at your formula sheet, you'll see that the relevant equation is for the pressure and volume of gases at constant temperature, which is exactly what we've got here. And the equation is P1 V1 equals P2 V2. Well, what does that mean? Well, it means that the pressure times the volume of the bubble at depth is equal to the pressure times the volume of the bubble when it's at the surface. Okay, so we're told, let's take this at depth. So 1, the ones refer to at depth and the 2 at the surface. Looks like surface is at depth there. Don't like that. Let's get rid of that. Because of that, we're going to swap around. Let's have, just because of the proximity, the way I've drawn it, we'll have this. Whether you choose this one to be at the surface or depth doesn't matter, as I hope this is showing. Okay, we'll have 2 at depth, right, referring to depth, and 1 referring to the surface. Okay? Right, so we're told that it was 23 cm cubed at depth. So that is the volume at depth, which we're using a 2 for. So that is V2. Okay? We're told it had that pressure at depth, 2 is depth, so that must be P2. Right? We want the volume at the surface. Surface is 1, so that's V1. That's what we want. And the atmospheric pressure, that's the pressure at the surface. So that must be, surface is 1, that must be P1. Right, simple. So we want V1. So we rearrange this for V1. That's easy. V1 is P2V2 over P1. And now we just stick in the numbers. So that's equal to P2, 297 kilo pascals. 1 pascal is equal to 1 Newton per meter squared. That's the correct unit, the unit you should work in. Times V2. V2 is... Now, I know I always tell you to work in meters squared, okay? And you could be forgiven for converting that cm cubed, or meters squared, meters, or meters cubed. You could be forgiven for converting that cm cubed into meters cubed, okay? However, if you look at the answer sheet, it wants you to give the answer in cm squared. So we're going to leave it at cm squared. Okay, so it's times 23. P2, V2, all divided by P1. Atmospheric pressure is 101 kilo pascals. Good. Stick that in your calculator and you get 67.6336 something something something. Let's go to 1 decimal place, sensible choice. 67, that 3 leaves the 6 alone, 67.6 volume, and like I say, we're working in centimetres cubed, so centimetres cubed. Quick check, is it a sensible answer? At depth it was 23, at the surface it's 67. Yeah, seems reasonable. Good. Okay, next bit. A girl is doing an experiment. She has several wooden blocks, a set of weights and a tank of water. Okay? She wants to immerse the blocks fully to investigate the relationship between upthrust and weight of water displaced. So she's investigating the relationship between the weight of water displaced by the block and the upthrust. Okay, question. Describe how she should determine one of the variables in this investigation. Okay, 2 marks. Well, do what the question tells you. It wants you to describe how she should determine one of the variables. So pick one and focus on that. You're not allowed to do 2. So what are the variables? Well, she wants to investigate relationship between upthrust and weight of water displaced. So our variables are upthrust, okay, and weight of water displaced. Weight of water displaced. So like I say, pick one of those 2, focus on that for the 2 marks. Right, so let's do upthrust first. Okay, so the wooden block is floating in the water, okay? Some of it will be sticking out of the water. She has to keep adding weights until the wooden block is just submerged below the level of the water, because then it's fully submerged, okay? And the block is fully displacing an amount of water equal to, a volume of water equal to the volume of the block, okay? So, keeps adding weights till it's fully submerged, and it would be equilibrium then, motionless, which means that whatever the upthrust is, which is what she's trying to find out, it'll be equal to the weight of all the weights she's added and the block. Okay? So that's basically it. So upthrust, add weights until it's submerged. And then the upthrust equals the weight of the block, which she can weigh before she does this, ideally, so it's still dry. Weight of block plus the however many weights she added. Okay? Good. Now, what about the weight of the water displaced? Well, get out a ruler and she needs to measure the dimensions of the block, okay, to work out volume. So ruler, block, dimensions, and then she can work out the volume of the block, okay? Now, the volume of water displaced equals the volume of the block. That equals volume of water displaced. Okay? So you've got the volume of water displaced. She knows the density of water. So we're going to use density equals mass over volume. So therefore, mass is density times volume. So she knows density of water. She knows the volume displaced, so she's got the mass, right? And finally, the weight is equal to mg, forces mg. Mass times gravitational field strength. So the weight is equal to mg. Okay? Right. Good. Let's move on. Okay, so this bit here. This thing here in the submarine is a buoyancy tank. Okay? And there's some water in it there at the moment. The way submarines work is that they pump in air from a compressed air supply inside the submarine into the tank to force the water out, and that increases the volume of air in the buoyancy tank, decreases the amount of water in the tank, and that decreases the weight. So the submarine rises, and then they allow water into the tank, increasing the weight, the submarine sinks. But we're going to talk about that now. Okay, so explain how pumping water into and out of the buoyancy tank affects the depth of the submarine. Okay, 6 marks. All right, so first thing to say, let's label the forces on the submarine, okay? The submarine has a weight, okay? That's trying to pull it down to the bottom of the ocean. What's holding it up? Same as here, upthrust. Okay? Right. So, label the diagram, draw a little diagram yourself if you want to label it. Or at least, if you don't draw a diagram in the exam, write weight down, upthrust up. So there are 2 forces. Say that there are 2 forces acting on the submarine. Okay? Upthrust and weight. Now, next, say that upthrust is equal to the weight of water displaced. Weight of H2O displaced. Okay? Now, next, I would say that the volume of the submarine is constant. Volume of the submarine is constant. Okay? And therefore, the weight of water displaced is also constant. The weight of water displaced is constant. And therefore, because the weight of water displaced is upthrust, upthrust is constant. Okay? No matter how deep the submarine is, upthrust is constant. Very important. Okay, so next, allowing water into the buoyancy tank increases the weight of the submarine. So water in to the tank, weight of the sub goes up. Okay? You have to write this out in full sentences, obviously. Okay? Because the volume of the submarine is constant, if you like. Okay. Allowing water into buoyancy tank increases the weight of the submarine. Okay. Good. When this weight of the sub becomes greater than the upthrust, then the sub is going to sink, because the resultant, good idea to get this down, the resultant or the overall force, probably use resultant, slightly better than overall, the resultant overall force is down when the weight is greater than the upthrust. Yeah? Okay. Now this last thing in reverse. When they pump out H2O, then the weight of the sub goes down because you've got water being replaced by air. Okay? So the resultant force is, weight goes down, so resultant force is up. Okay? And when, put that there if you want, when the weight of the sub becomes less than the upthrust, then it rises. Whew, and that should get you the 6 marks. So, just to summarise, to get the 6 marks here, you've just got to be patient and write everything out in full, okay? Don't try and skimp, do it quickly. I know it feels like you're repeating yourself here. It's just when you're saying what happens when the water gets pumped out. You follow the process and it rises. It's just this in reverse, but write it out again. you will lose marks if you just try and do this quickly, say, oh, then this happens in reverse or something. So write it out in full like that. And there you go. That's the sort of thing you should be aiming for. Okay, finished.